Experiment number 2. Disturbed soil sampling, labeling, and storage. This activity aims to introduce the use of hand auger for obtaining disturbed soil samples and the standard method of storage of soil for future laboratory USE. Throughout the experiment, the students shall be able to understand the standard procedure in soil sampling and handling and perform the soil profiling as observed from the results of the experiment. Before that, the simplest method of soil investigation and sampling is through the use of auger borings. This method is applicable for retrieving disturbed soil samples that are to be tested in the laboratory to further determine its engineering properties. However, it is important to be reminded that improper handling and storage of the sample can compromise the integrity of the soil investigation conducted. A standardized labeling of the sample is beneficial as the soil sample, in general, is handled by different personnel in the field investigation and in the laboratory. It is important that all pertinent data observed on the field are to be written down in the sample label in addition to the primary record book of the site engineer. The data in the sample label will direct the laboratory personnel in finalizing the borehole log, which is to be counter-checked by the site engineer's primary record book. For able to start the experiment, you will be needing soil auger if applicable, spade or shovel for able to dig the soil, some containers to store the samples, and pans. These are the steps that you will follow. First, select your preferred location. Our selected location is at Tanawin Road, Tungkang, San Jose del Monte City, Bulacan. Next, clear the area of grass and vegetation where the soil samples will be collected. Establish an alignment of 3 boreholes, spaced approximately 3 meters apart, using appropriate digging equipment. Bore the soil until the required depth is reached. For every 0.5 meter depth advancement, collect a soil sample for examination and testing. Record the corresponding depth and all relevant observations for each retrieved soil sample. Seal each retrieved soil sample in a container and label it properly to preserve its condition and identification. Continue extracting soil samples during the succeeding borehole advancements until a depth of approximately 2.02, 3.0 meters is reached. Repeat procedures 1 to 4, borehole number 2 and 3. Then prepare and draw the site stratigraphy based on the observed soil layers and collected data. The soil profile in borehole nitrogen monoxide 0.1 showed a gradual transition from loose, coarse-grained topsoil to denser and more cohesive clay-like material with increasing depth. The upper layer consisted of light brown soil mixed with roots, leaves, and small rocks, while the deeper layers became darker, denser, and more difficult to excavate. Dark orange clay-like soil and embedded rocks were observed at greater depths, indicating increased soil compaction and stiffness. Overall, the investigation revealed distinct soil stratification and provided important information regarding the composition and engineering characteristics of the site. The sealed soil samples should kept in place. Make sure that it is sealed appropriately to make of the best experiments results. These samples may use to future experiment where you will be needing the soil samples. The manual excavation and soil sampling conducted at Tanawin Road, Tungkang, San Jose del Monte City, Bulacan successfully demonstrated the standard procedures for obtaining, labeling, and storing disturbed soil samples using basic excavation tools, such as spades and shovels. 3 trial pits were excavated to a depth of approximately 2.0 meters, revealing a consistent site stratigraphy that transitioned from light brown soil near the surface to dark orange clay-like material at deeper layers. The systematic sampling procedure, together with the proper sealing of samples in moisture-tight containers, helped preserve the physical condition and integrity of the soil for future laboratory testing. The collected soil samples and field observations provided important information for identifying the geometry and characteristics of the soil layers, which are essential in evaluating the suitability of the site for engineering and construction purposes. Thank you so much for watching. I hope you learned something today.